Okay.
Okay. A very good morning to you all. I, Dr. Chandni Sharma, Coordinator First Year BTech and Diploma, Quantum University, is delighted to welcome you all to the second Virtual Power Seminar being organized by ICT Academy and Quantum University, Berkeley. The talk of this seminar is Scope of Artificial Intelligence and Machine Learning. The idea that a machine could exhibit same levels of intelligence as that of a human being has captivated scientists for decades. That day is nearing. AI enables a machine to simulate human behavior, and machine learning is a subset of AI that allows machine to automatically learn from past experiences as our brain does. AI is not about building a robot. AI is not about building a robot, but developing a computer mind that can think like human, learns, approaches, and even exceed human levels of intelligence. AI machine enables a computer to do what humans do. It enables us to see like through image processing and computer vision, hear and speak through speech recognition and natural language processing, reason and analyze similar to our brain using pattern recognition and react through actuators as robotics. AI has a potential to change various sectors, be it scientific and research, defense, data security, social media, entertainment, agriculture, healthcare, education, and many other spheres. To explore how is AI making significant impact in these areas and how it works and solves complex problems in efficient way, we have with us today two experts, Dr. Pranjal Kumar Fukan, Director, International Council of Technology Management and Applied Engineering, and Mr. Prabhakaran Chandran, scientist from Mu Sigma, Bengaluru, Karnataka. We welcome both of them. So let me introduce you with the first speaker of the session. I have the privilege to introduce our expert, Mr. Prabhakaran Chandran, data scientist at Mu Sigma. He is a young data scientist with more than 2 years of experience, has been working with Fortune 500 clients to solve their problems using power of artificial intelligence and data scientist. As an avid learner, he always looks for learning and experimenting opportunities and is passionate about upskilling everyone. As a part of data science journey, he has been mentoring colleges and students and enabling them with data science and machine learning skills. Mr. Prabhakaran has modeled and controlled systems using soft computing techniques and worked in areas of demand forecasting, prediction, analysis, agent-based modeling systems, data-driven failure management systems, etc. So now I request our expert to deliver his talk. Sir.
Hello, everyone. Am I audible? Hello. Hello. Let me test.
Yes, sir, mine is making sound.
Okay.
So kindly turn off the mic of one of your system.
Okay, sure.
So presentation is visible.
Okay. Yeah. Good morning, everyone. Thanks for ICT Academy and Quantum University for hosting this wonderful power seminar on scope of artificial intelligence and machine learning. Today, I have taken a few of the industry verticals so that we can discuss the scope of AI and ML across different industry verticals, and then how AI and ML is useful for saving time and reducing the manpower kind of things and all we can discuss today. And then few of the I'll be talking about few of the algorithms also, so that you guys anyone interested in AI and ML can start with that, can take a project in that particular industry and do it. So the following industries process industries, manufacturing, agriculture and food tech, social media and entertainment, biochemical sector. So these are the industries that I'm going to talk about today. What is the scope over there? What kind of applications? What kind of case studies that we can see over there? That we will discussing over there. Like with respect to myself, I'm working as a data scientist. If you want to follow me or if you want to collaborate with me, you can visit my website, prabhakarchandran.com. Otherwise, we can get connected in LinkedIn. If you have any kind of if you have any kind of doubts over there, or if you want to do any projects, we can collaborate also. So the first one is process control and deep neural networks. So when I say process control, it is nothing but in process industries like petrochemical industries, or even in refineries, or kind of like sugar mills and bioreactors and all. They are called process industries. So every time that that particular system, our plant involves with many input and output. For example, if our output is one of the output is the output is output of the product, like flow of the product. If the flow of the product is to be maintained at 10 meter cube per second, so we wanted to control our product so that we can maintain that. 1 second, I can take. Okay, we can maintain the desired output stable. So this is the actual control system, like a normal process control system. We all know, like in control theory, or in even a normal life, like everything is based on feedback. Like we are learning something from the feedback, like from the output, we are calculating some error. Like what is the desired one? Like what is the desired one, and what have we gotten? So based on these two, like we are calculating that error. Like based on the error, there should be some controller to control and to maintain the output in the output as equals to the set point. The same way in a control system, in the process control, there is a controller called PID controller, which is program, which is like P means proportional, I means integral, D means derivative. So proportional integral derivative control is there. It is like one of the major controller in control systems. Like that will try to map this errors. That will try to reduce the error such a way that like we can get the output as equals to set point. This is what control system work. This is how process control work. But sometimes this PID controller may not be able to handle complex systems, because like here we have only one input and one output. Like for example, in a real time system like a petrochemical industries, or like a chemical processing industries, or kind of bioreactors and all, like we will be having n number of inputs and n number of outputs. Whereas like this PID controller may not be able to handle that. That is why we are trying to replace this PID controller using, sorry, trying to replace this PID controller using neural networks. We all know about neural networks. Neural network is artificial neural network is inspired from biological neural network. It starts from 1940s, like McCall Spitz. They are like the first inventors of like mankind artificial neural network. That is to just mimic or like replicate how the actual biological neuron works, as in that biological neuron will take the electrical signals from the other neurons, and it will try to translate, or it will try to convert into some other signal, right? The same way, the neurons, the artificial neurons will take some one set of inputs, and then it will try to learn and then try to produce the output. That is based on backpropagation. Here we have considered like a multi-layer perceptron, which means like we will be having like n number of layers of neurons. For example, if we have like 5 layers of neurons, each layer has some 7 or 8 neuron. So that will form a multi-layer perceptron. So to train this model, to train this one, like we are giving this error, and then like we are backpropagating the loss. So based on that, the neural network, which is a multi-layer perceptron, will try to learn like how to accommodate with respect to the error. Like if I get some error around 200 or 300, how should I react? If I get the error like 100 or 50, how should I react? This is how this neural network learned things. So once it learned things from the PID controller, the existing controller, we can remove the existing controller, and then we can replace. Sorry, we can replace and have the control system only with deep neural network as a uh, PID controller. So by using that, we can handle n number of complex inputs, and also it is like thinking like a human. It is learning from the historical way instead of calculating in the derivative equations. It is actually learning something from the past. So this is the difference between normal PID controller, because PID controller is constituted by the equation, like 1 or 2 equations, whereas neural network is based on historical learning. Like, okay, like this is how we gotten through last 3 years or 4 years, or even like 4 months or 3 months. Like this is how the relationship between error and output, control output looks like, so that we need to adjust our weightages based on this. So once that neural network learned, we can replace that existing conventional PID controller into a neural network controller, so that it can easily control the processes with respect to the changing, with respect to the disturbances, and also we can change the set point also. Based on that, we can achieve desired output continuously without any kind of anomalies in that. So this is one of the scopeful area where deep neural network or like artificial intelligence play a major role. I would say like whenever anyone want to comes in artificial intelligence, or like step into data science like emerging domains, I would suggest them to learn this as a extra skills, whereas they can add this extra skills to the existing domain. For example, if I am a chemical engineer, I need not to switch my career. I need not to work completely as a deep like artificial intelligence engineer. Instead of that, we can add this artificial intelligence, add this flavor of artificial intelligence to the existing chemical engineering industry, or existing electronics industry, or existing mechanical industry, so that while adding AI to your domain, it will become a lot of like a scopeful area. Instead of just running behind the recommendation system, or just running behind the sales driver analysis, you can build a number of cool projects over there. You can work on cool projects. With a lot of companies are emerging with respect to all the core industries. So it would be helpful for you when you have like additional skill called like artificial intelligence or machine learning. You can just add it to the existing one. For example, in mechanical engineering and all, we are developing this finite element analysis. That finite element analysis can be replaced with kind of like deep learning methodology. Or if we are doing topology optimization for the CAD designs, we can replace it using the replacing it using the neural network. So the industry is same, but methodology is going to differ. Methodology is going to occupied by AI, so that it will increase, it will improve the productivity, and it will improve the work quality. So this is the one of the tip that I have. Like instead of changing the domain, you can be in the same domain, but you can add an extra flavor called AI over there. So the next that's why I have taken like most I have taken the industries like very which is related to any other any other industry, like any other departments also. Like it is not only made for computer science and information technology. It is for everyone. It is for human beings. It is for the society. Artificial intelligence is for society. So it shouldn't be like called only, okay, I am a engineering background, only I can work on artificial. It is not like that. Anyone can work on artificial intelligence. Anyone can work on things which is creating impact for the industry. So the next one is like manufacturing and quality control. So in a huge manufacturing industry, in a kind of um, a kind of like car manufacturing or even mobile manufacturing companies, like we will have a lot of sensors, industrial sensors, right? Industrial sensors. So these sensors are like automatically connected to the data lake or cloud system using IoT, Internet of Things, Industrial Internet of Things. So this streaming sensor data can be stored continuously in the cloud data lake. Once we like make this data in a structured way, and then once we make this available to everyone, like we can perform production or assets health monitoring, because like there are a lot of sensors like vibration sensor things, and then vibration sensor, temperature sensors, and the gas, humidity. A lot of things are there with respect to a particular industry. For example, if we are using a food processing industry, there will be like a humidity sensor going to play a major role. Humidity sensor. Hello, am I audible? Is everyone is
Yes.
here? Okay, okay, got it. So, likewise, the types of sensors will differ with respect to industry, but the usage of sensor is going to be same at most. So while we have this, why did I mention the streaming? As in, like for every second, the sensor will try to measure things, like how our Fitband is measuring things for every second, right? The same way, sensors will measure things every second. So it will start streaming the data, start transferring data to the cloud data lake. Once we store that, once we process it, so it's not just running an algorithm. So it is actually AI is actually like designing the whole system. We cannot just the algorithm which is in a Python notebook or which is in any kind of IDE will not help at all. It will be like just like sleeping, right? We need to bring that to the existing system, which can be helpful for the users. That is why we need infrastructure, like right from collection of the data, which is from industrial IoT, which is from industrial sensors to the IoT protocol, and then that streaming data has to be processed and stored in the cloud data lake using data engineering, ETL, extract, transform, load. And then once we store the data in the cloud data lake, we can use like either visualization tools, or SCADA is also there, which is to monitor the process and all. Um, so we can monitor the production, like how much production is actually is going over there, and then assets health we can do. Along with that, we can perform the anomaly detection, which means like based on the sensor data, like based on the sensor outputs, we can perform a machine learning algorithms, like anomaly detection algorithms, to capture, okay, this is an anomaly, what could be the reason, and what can be the respective remedies that we can take up, so that we can avoid this anomaly in future, or we can overcome this in the as overcome as soon as possible. This is one of the thing that we are like that. A lot of companies are emerging over manufacturing and quality control side, like machine as in like manufacturing related artificial intelligence companies are evolving. And another one thing is like a quality control. One of the things is like the process monitoring, and another one thing is like anomaly detection, and another one thing that is where we can find the scope of artificial intelligence machine learning is automatic defect detection or quality control. Either you can take any kind of industry, that product would be anything, like even that product would be a packed food, or else like a machinery spare parts, or like a mobile like a chips, kind of things and all, right? So in the final product line, if you are able to embed a machine vision camera or IR cameras like infrared cameras, we can able to run the multimodal machine learning, which means like when we collaborate the sensor data along with the taken images, we can perform computer vision plus a multimodeling machine learning algorithm, so that we can check whether the particular product is quality enough or not. uh, and also we can judge how many defects are there, and also we can profile that defects, like whether those defects are highly vulnerable, which means like highly impactable or sensible or not. Likewise, we can profile the defects also. Since I have worked on it, like I wanted to put it because even like interested people, like those who are from manufacturing or mechanical, automobile, electronics, instrumentation kind of a field, they can use it as a project idea. They can use it as a like a master thesis or bachelor thesis idea and go forward. Even a lot of companies are even companies from APAC region, like which is Southeast region, where a lot of uh, more income or more GDP is based on automotive or like a production sector, even a production sector, right? In those places, like to reduce the manual power in checking each and every products, they have implemented, like they have started implementing machine vision based automatic defect detection, so that they can reduce the time and also manpower. One of my personal project I have done is like automatic defect detection, automatic like failure or kind of like rotten vegetable detection on the conveyor line, so that by embedding this machine learning algorithm as a feedback to the robotic arm, it will automatically remove it. It will automatically pick and throw the rotten or like damaged food items. That is one of the thing I have done during the my college time, like using PLC has been used for robotic arm, and then machine vision cameras and algorithm, which is computer vision algorithm, to classify based on the captured images and also some other parameters that was used. So you can use any kind of neural network architecture to perform. Like the major architecture used there is object detection architecture, so that it will detect the place where exactly that defect lies on, that we can automatically detect. So you can go through the object detection algorithms like faster RCNN, like a retina net, trident net kind of things and all. You can go through. Even new algorithms called efficient and efficient net are available. So it would be like quite exhaustive, but the thing is, like I wanted to put an important things so that you can take notes. When you have some time, you can like go through it. You can like start from anyone. For example, here I have like talked about like streaming sensor data and how that sensor data is transferred to the cloud data lake through the ETL process, like through the data engineering process. You can start your career or you can start learning data engineering also. Otherwise, if you want to like step into like a business analytics or like kind of business intelligence part, you can take up this part, which is where you can perform like productions and assets health monitoring. And machine learning algorithm is being used here. You can start with very simple machine learning algorithm, which is regression, and go reach till neural networks are nowadays like graph learnings are emerging. And then in this place you can you can learn about computer vision along with reinforcement learning and all. You can learn. So reinforcement learning is nothing but like the model or the robot itself will start learning it without any supervision. But the only one thing which is to the controller as a human being for us is to provide a correct reward. So reinforcement learning is completely based on reward, as how people are learning. So if I am learning and I'm writing an exam, if I write that particular exam properly, I can get some grades, I can get some awards and all, right? That award is motivating me to pursue in the proper way. If I am not at all getting an award, I'm doing something wrong, or I'm not like reaching that much level, right? The same way machines will try to get the rewards, will try to increase the rewards as much as possible. uh, to get the more rewards as much as possible, it will learn a kind of strategy. That strategical learning is called reinforcement learning, which is mostly used in robotics and then robotics arms and all. you can Google Boston Dynamics, where you can see a robot and a robotic dog is dancing. That is completely based on reinforcement and intuition, um, like imitation learning process. And the another one thing is like the third industry that we wanted to talk about is agriculture and food technology. So in agriculture or in farming, like there are two things. One is monitoring crops, uh, and another one is um, livestock, which is like chickens, roosters, and even sheep, cows, and all, right? So in even in TensorFlow, you can see like TensorFlow has developed a flagship model to help the cassava tapioca farmers in the African continent. So by developing a computer vision model, we can easily detect the diseases, what kind of diseases like disease is there in the crops, and then based on that we can classify it, and then we can provide the remedies. Like by developing a small agriculture or farmers app, by collating it, farmers can go to field, and then they can just take the picture. Based on that system will classify what is the disease that is occurred in the crops, and then that can suggest the remedy. Like you can use this fertilizer, or you can follow this methodology. Like you can use kind of like neem oil along with some fish oil and mix it up, and spray it over there. It will cure the this particular disease. Likewise, by collating this computer vision and natural language processing, we can build a farmer-friendly recommendation system. And then another one is like field health or crop health monitoring by using like field sensors like humidity sensor, temperature sensor, and then by using some kind of chemical sensors like NPK, nitrogen, phosphorus, potassium sensor, we can monitor like how much, what is the quality of the soil, or what is the whether we have enough amount of nutrients or minerals available in the soil, whether will it help a particular crop. It is with respect to particular crops only. We cannot generalize it, because for a sugarcane, the land quality or like field quality should be in a particular level, whereas for paddy or for tapioca or cassava, it should be in some other range, right? So by taking the inputs from the sensors, and by doing the crop level anomaly detection and field monitoring, we can understand like what actually is the soil quality, and what we need to do, whether we need to put some fertilizers, urea, potash kind of things, or whether we need to put some other mineral related um, fertilizers or not. And another one thing is livestock. There is a company called Flocks.ai that is famous for its like livestock monitoring. Whereas like they used embedded like machine vision cameras like IR or normal machine vision cameras. They are like by using that camera, they could monitor the livestock movement, and then health monitoring and all they can do. Like just by doing the two things, by collating two things. One is like the atmosphere monitoring using the sensors, like what is the temperature inside it, humidity inside it. Because for poultry, because for chickens and hens and all, like the humidity is important, temperature is important. Then only like then only we can avoid the like virus spread, because like a people birds like rooster, chicken, hen and all affected by this like bird viruses. So to avoid that, it is important to monitor the temperature and humidity inside the sheds. So that we can do by uh, like placed embedded sensors. Along with that, to monitor the movement, like if there is any kind of chicken has died over there, or is there any like a congestion, or like whether the distance, or whether they are able to get the proper ventilation or not. Everything we can monitor it. You can just visit the website called flocks.ai. They are providing this like integrated embedded system based livestock monitoring system. The same way we can use it for dairies also. So this is how like we can empower, we can reduce manpower, or we can increase the productivity using artificial intelligence. When I say artificial intelligence, like it's going to be constitute any one of us, like deep learning model or machine learning model or probability based model. But the thing is, when actually that is going to be called as artificial intelligence, when we have an end-to-end system, like when we have an intelligent system which can handle everything without any human intervention, right? Along with the proper infrastructure, with the just model, with the just IB1 by file or .py file, it will not be called as AI. So it should be really creating some business impact, and it should actually reduce that human intervention, and it should also consider the proper infrastructure. So we have covered three things: process control, manufacturing, agriculture, and food technology. The fourth one is social media and entertainment. It is very close to us, everyone, for very close to everyone, because like for agriculture and all, we would have visited a farm, any one of the farm, a year back or 2 years back, or someone of us, like many of us wouldn't have visited so far, right? But social media and entertainment is like we are using it every time. Like we are using like till the last minute, last second, right? Something is coming continuously popping out in our mobile phone. So social media platforms like Facebook, Instagram, or like LinkedIn and Twitter and all, like they are using machine learning, artificial intelligence in any number of ways. I have put few of the important cases. One is like offensive language or hate speech or fake news detection using NLP. So Twitter is using this extensively. You could have seen like you could have seen like few of the politicians' tweets, or few of the like even American president's tweets and all. Like it will automatically say it is involving some like false statements or like offensive statements, or even when you talk about COVID, it will automatically put COVID related information. So like to judge, to classify, to detect what kind of entities are being spoken over there, NLP is widely used because over the, like widely used in Twitter. And another one thing is in Instagram. Like if you post anything very like kind of vulgar thing, it will automatically say, "Do you want to see?" Kind of like that will show some warning, right? That is based on like multimodal things, like what is the content over there in the video, or content over there in the image, right? To classify whether that is good for the society or not. That you can detect in the social media. That is one of the use case. And another one thing is like personalized content. When we talk about this Pinterest or even in Facebook, Instagram Reels and all, the Reels will differ with respect to our interest, right? That is based on deep nets, like either by collaborative filtering or content based filtering. That is one of the major recommendation system algorithms. We could get proper personalized recommendations, even in um, online streaming platforms like Netflix, Prime Video, Z5, kind of things and all. Like they are personalized, like they are creating a personalized playlist. That is like if you take this. If you take one of the major playlist, what is that? Spotify, right? Spotify understands our like our preference, our like kind of like what kind of videos, or sorry, what kind of songs that we have listened to it. Based on it, it will automatically suggest a new song or new genre, and it will automatically create a kind of playlist, right? It's based on a recommendation system built using deep neural networks, or deep neural network, which is like based on either by collaborative filtering or content filtering. So content filtering is which is nothing but if I am watching some movie which is related to a thriller genre or like a crime genre, the recommendation system will automatically recommend us some other movie which is related to the same um, genre. This is content based filtering. Whereas in collaborative filtering, if my friend is watching series something related to like a documentary or crime thriller, if if I am the same person, if I am the same behavioral person, which means like I'm as equal to my friend, I will be notified, or I will be recommended with the crime thriller kind of thing. That is a collaborative filtering based on the other users, based on the like like-minded user. Right? That is one of the things. And targeted audience filtering and marketing. This is like widely used for any for all the companies, for all the market, for all the B2C companies. They wanted to target audience, but they wanted to target proper audience, like not like everyone. Like for in an Instagram, if we have like some 100 million users, we cannot target everyone. We cannot send a message to everyone, right? We wanted to find out like who can possibly like who can possibly turn out or like convert into a business or like a actual customer, right? We wanted to target it by using a proper like classification algorithms. We can filter out like what kind of audience that we can target. Then once we target it, we can provide it to any kind of like a market, social marketing, digital marketing companies. They will automatically send the personalized marketing emails or marketing ads to their platforms. So actually, most of the income is coming from this kind of thing for Facebook and Twitter and even Instagram and all. So even if you are doing digital marketing, if you can visit Instagram's advertisement page. You can fill something, right? What kind of, how many audience that you want to target, and what kind of audience, right? That kind of audience targeting, like that profiling that audience is done by Instagram's algorithm. Like whether you are interested more towards a particular like fashion products or like electronic products, something, right? And the same thing you can see like whenever you are visiting some e-commerce websites, like if you are searching for something, the same kind of ad you can see it in Instagram or Facebook. So that connectivity, that profiling the customers and that targeting the customers is completely done by this artificial intelligence, machine learning. And another one is like when we are using Facebook, like it will try to automatically tag ourselves. Even if you post some group of people, like it will try to recognize the um, faces. If those faces are in your friend list, it will automatically try to tag it. And for not save for work, which is NSFW content, like in Twitter, in Reddit, in Instagram, it will try to predict it. It will try to give you the like warning, like it is NSFW, you should not enter it. If you want, you should be like 18 plus, or you should have some like like some warning it will give. It is purely based on computer vision and NLP, because like we cannot just judge the content based on video. So there should be like or we cannot judge the content based on only on text that is over there. So by improving to improve this kind of detection technology, which is NSFW or like face recognition technologies, we would need like a multi-modeling things. For face recognition, we wouldn't need a multi-modeling, whereas in NSFW or kind of fake news or offensive speech and all, like we would need computer vision and NLP, so that we can combine the text over there, which means like in a post there should be some content and along with it is some text. By analyzing both of them, we can say it, okay, this is something like offensive, or this is something um, fake kind of things. Actually, Twitter is doing it properly, and Instagram is doing it for kind of copyright purpose and uh, like very small in scale for like the stories. When someone puts story about like mob lynching or like some kind of uh, what is it kind of criminal activities, someone is posting about it, it will automatically try to give the warning, right? You would have seen that. So this is one of the use case. And when it comes to online streaming, there is another one thing. Even when it comes to any kind of like online platform, the one of the major thing is like every time we wanted to search about something, like we want like in LinkedIn and all, like we wanted to like search employee, or even in Twitter we wanted to search particular like a particular term, and even in Netflix and Vimeo or YouTube and all, like we wanted to search some videos, right? So this is not based on, the search is not based on just a string matching. It is going to be a semantic search. Semantic search is nothing but, for example, if I talk about like today I'm talking about like online streaming. And someday, if I want to know about what is hope speech, or what is click through rate, or what is kind of collaborative filtering. It will not just give us retrieve the results only for the word collaborative. It will try to bring the words or content related to collaborative. That is why we need the semantic search. The semantic search is completely based on neural networks and knowledge graphs. Knowledge graphs is nothing but connecting everything based on connecting everything, which means like instead of storing things in the tabular manner, we wanted to make a graph kind of structure that is called knowledge graph, which means like if I am an employee of a company, so we will be connected together as a nodes. The same way, if everyone connected and everyone forming a semantic web or knowledge graph, it will be easy to retrieve the information. It will be easy to find the proper search term, or even if you wanted to perform some travel and salesman algorithm, or kind of finding out an important nodes and all, we can easily do it using graphs. So graph learning and knowledge graphs are evolving systems. And Twitter is using knowledge graphs, LinkedIn is using knowledge graphs, Microsoft 365 is using knowledge graph to have a proper even Google. If you search about like Barack Obama, or if you search about MK Stalin, or if you search about any like Jagan Mohan Reddy, like you can see a card over there in the Google Chrome page, a small card where you can see like what is his name, what is the particular person's spouse, where what is his kind of like another details you would get it, right. So this is based on like the knowledge graph where you can get the immediate information over there and put it as a knowledge window kind of thing, like a small card where you can get the snippet or history about that particular person. If you search about anything, even if you search about a social media, it will be there. Like instead of just listing the um, um, just listing the URLs, in the right side you can get the you will be able to see the card where you can get all the additional details, like in the concise, comprehensive manner. That is based on this knowledge graph. And the last thing is biochemistry and healthcare. Three things: biopharma, which is biological industry, and another one is chemistry, chemical industry, chemistry related research, and healthcare. So when it comes to biopharma, the important thing is like applied drug discovery. So applied drug discovery is nothing but like what kind of like how the chemical molecules or drug molecules are interacting with the genomes, gene patterns. Like when we are able to do that, like we can get to know what is the properties or what kind of structure we can see, or what kind of adverse events we can see. So this is like most of the neural networks. Like there is a neural network family called GANs, which is generative adversarial networks, that are useful in generating new kind of genomic structures or genomic architecture. That is one of the things. And another one is like by analyzing the clinical data. For example, if anyone involves in cancer research or oncology research, they need to analyze like what kind of symptoms is being seen over there, like significantly, or what kind of survival rate we can see, kind of analysis and all we can do it using machine learning. So if you want to get more important, like what if you want to get the proper mathematical background, you can start it from here, like how we can use machine learning for like clinical data diagnosis and symptom profiling, that you can do, and a lot of research papers are available. And one of the major thing is like even for a companies, for a huge research related company, they wanted to get some direction, right. If they wanted to get some direction, usually everyone do research documents, like they will download it from some science direct, elsewhere, ACL digital library, so they cannot go through it, they cannot filter it, right. It will take more time because everyone, they have to read at least an abstract, right. So in order to avoid that, like the research document analysis, classification of documents, and then detecting the entities, important entities, can be done through natural language processing. Like we can easily model the topics, like okay, this particular paper talks about genomics, this particular paper talks about insulin and enzymes, this particular paper talks about like oncology research. And then if you want to search for important terms like coronavirus or SARS related research papers, or if you want to talk about like fungi related project related things like when we do this NLP based document analysis, NLP based document profiling, like what kind of topics are discussed, what kind of entities are present over there. We can use NLP so that we can easily get the proper research papers in a quick time instead of like going through everything one by one. And another one thing is in chemistry we have like material discovery. Actually, like material discovery is like nowadays like material informatics or material discovery is nowadays evolving in a like like in a faster manner, because like companies like additive manufacturing companies are like looking for like novel materials, because like they are manufacturing it for nuclear power plants, Formula One cars, are kind of aircrafts, space products and all, right? For that, they need new materials. They are not just looking for like a stainless steel or titanium or plutonium. They need some that like the kind of alloys, right? Like the combinations of materials. So to do that, to discover the proper material, like combinations of material, we wanted to analyze like if I create some this kind of combination, what would be the um, characteristics? What would be the strength or mechanical or tensile strengths, right? To do that, new deep learning networks are available. Deep learning networks are useful in terms of material discovery, and as well as in healthcare, we know medical image diagnosis, which is a broad and which is reached most of the people in computer science or even in engineering domain, like a medical image diagnosis, like to classify like in images or to detect tumor cells, cancer uh, affected places, and then like pneumonia or tuberculosis, or even like kind of cysts formed in pancreas or digestive system. Everything can be diagnosed using neural network, computer vision based neural networks. Either it is from CT scan, or it is from ECG, or it is from 3D MRI slices, that we can do it using computer vision algorithms like faster async, or like nowadays like medical or like clinical related segmentation models are coming, like unet or u square net and all, available to segment out the particular uh, affected area, so that we can perform using artificial intelligence. So these are nearly like I would have covered like 5 to 6, nearly like 30 use cases across different industries. Like you can take any one of it, you can start your research over there. I would say like start collecting the data. If you are doing a project, for example, I assume like here we have some postdoctoral or doctoral or master thesis students would be there. They can start the research from the data collection part instead of just looking for the existing data. We can start collecting data from like for drug discovery and all. We cannot get it like easily, but with respect to
Super sorry for inconvenience. Please, can you hide this one thing that is coming below your presentation? You click on hide so that the interruption may be clear for the visual.
okay,
Yes,
yeah,
yes.
this is
Thank you
like
very much. Thank
yeah, this is for skin can. So this is for like I guess retina related issues, like um, because of this diabetes. People used to get cat like kind of issues in their retina, and then this is for the last one. The fourth one is for skin cancer, and after that like we can analyze the x-ray to classify to get the comorbidities or like pneumonia, tuberculosis symptoms over there. So these kind of things we can easily do it using the biochemical things. But when we collaborate with domain experts, we can build a quality product in AI instead of just having one-way information, like which is okay. I know deep learning, but I don't know how to profile or how to annotate the images. That we need domain experts like those who are from radiology or from normal doctors would help us. Like, okay, this kind of patches are actually defining a skin cancer, and this is not. This is just a scab or something else. Likewise, we can do. So, if you have any questions so far, like across biochemical, healthcare, social media, entertainment, agriculture, food technology, manufacturing, quality control, process control. If you have any doubts, or if you have any doubts about a particular algorithm, which means like particular jargons that that I might be used, and any case studies you can ask. I didn't explain much about the math behind the algorithm. When I say computer vision, I didn't explain because like that would require at least like half an hour to 1 hour to explain like what actually is convolution, how can we construct our own architecture, or what are the like significant architecture available in the like open source. That will take more time. But to give the gist about like what is the scopeful areas for AI and ML across different unique areas that I have covered. If you have any doubts, you can ask. If you have any questions, you can ask. We can discuss. By discussing it, like that might rise project ideas.
Yes, students, do you have any doubts related to the session? Sir, actually, some of the students, they are watching it online. The session is being streamed on the online, so therefore, means they cannot ask queries.
Okay. Or
Naresh
anyone
sir
from
and
this,
some faculty members are there.
yeah, faculty members can ask.
Uh,
Yeah.
Okay. Thank you very much for the session. Very interesting session, and the
so
application
there is a
domain was very
question.
interesting. Hello. Audible from my end? Hello.
Yes, sir.
Please
Yes, sir.
speak up from the audience.
Yes, sir. Yes,
Hello.
sir.
Okay.
Yes, sir.
Please
You
just
are
go to
audible.
the last slides that you have given plenty of the application domain that is attracting to me. Really
Okay.
interesting. Yes, last slide, please.
Are you able to see my slide? This
Uh,
biochemistry healthcare.
yeah. Can you
Uh,
can you can you
So
can you
there is
move?
a question in the chat box.
One second. Like I'll finish the question from answer the question from Naresh Kumar sir.
Okay.
So
Sir,
Fine, fine.
one request I would mention that if you could please come up on the camera so that we can take your screenshots as well.
screen. Sorry. Like actually, I don't have a proper camera in my personal laptop. That is why I couldn't come over there.
Okay, sir, if
Yeah.
it's through mobile, then you can just means on your camera if it's possible.
Okay. I'll try. One second. Yeah,
Yeah.
sir. What is your doubt? Like, meanwhile, like, hello, Professor Naresh Kumar, sir.
Yeah, some of the discussion was going on. That's why I stopped myself. Is there? Hello.
Hello, yes, sir. Yeah. Proceed.
Some other discussion was going on, so I stopped myself. That's what the things
Okay,
I.
there is a question in chat panel, which is mathematics is
Okay. Carry on, please. Carry on.
yeah. So obviously mathematics is important for AIML because like when you start doing research, you cannot just use the existing one, right? You need to change it, or you need to work along like you need to tweak the model, or change the algorithm also. So mathematics is important. Without mathematics, we cannot do anything. Yeah, that is the question, sir. Sir Naresh Kumar, sir, you can ask your question.
Thank you very much for giving time and answering the previous questions. Thank you for your patience. The question is first not a question, but it is very good appreciation that from the last slides I am attracted much more because due to the recent time, the things are going on nowadays due to the troublesome situations around us. So these things, AI, ML, machine learning, or any technology that is connected to the medical science or healthcare or chemistry, biochemistry. That is a very nice idea to connect with these things. So first, my question is here, biopharma, right? Some medicine
Yeah.
is there, some chemical components are there. So how you are going to use some type of computer vision, machine learning, or IoT, anything can be. Just give a overall idea, not required to go to in deep, please.
One second, Madam Chandni Sharma, am I visible for you? Like my.
Yes, sir. I'm
Mr.
taking some.
Prabhakaran, yeah, you carry
Okay.
on, please.
Okay. Okay. So with respect to biopharma or any kind of like a life sciences field, one thing is like how can we speed up the research? That is one of the like major idea, right? With respect to this COVID like vaccine discovery itself, like there is a company called Samya AI. They have accelerated the clinical trial based on this AI powered patient's record profiling. So, which patient we can take it for this clinical trial? What kind of persons we can get it? So, so to speed up the research, either in the clinical trial phase or in the like defining the problem space, this NLP or like computer vision are being used widely. For example, tomorrow you are going to start a problem. Sorry, to start a project, you need some guidance. Whereas
Uh,
you don't. Hello.
Prabhakaran sir, please, that's as you mentioned, here NLP and talking about some drug discovery or some medicine kind of things, then how it is going to connect it, please, can you confirm for me? I'm a little bit doubt regarding this.
Oh, you want to know like how this NLP is connected with biopharma field?
Yes.
Yeah. For example, um, um, in a biopharma, you are doing some research. You wanted to take some research papers. You cannot read like a company or like in the research company.
Actually, think is that research paper is a different thing. First is the presentations and that some technology required. We heard that some you're talking about some features were taken from the medicines, right?
Okay.
Some component were taken in the form of some chemical compounds, right? So
Okay.
how to give training or that mixtures that can be generating a new mixtures or generating a new medicine for that. And again, the NLP is again a disturbing problems and disturbing terms in between. That's why I want to connect both these things as you mentioned here.
Okay. So you're saying you're asking about like how to connect this genomic patterns and all. Uh, c- so I couldn't understand the question. Can you say it again?
Okay, see, something that we are applying any technology, whether machine
Okay.
learning framework, IoT, or
Okay.
image processing or anything. So first of all, we should have some type of stuff, some type of data, right?
Okay.
And so from
Yeah.
the data, we have to extract something, some what you call some characteristic features that we need to train. Okay, from
Yeah.
the model we have developed. So from the question, first question was some medicine or some chemical compounds with you. Okay, talking about the first component biopharma, right?
Yeah.
So next things, what is the process in between that some arrows are shown? There's something like not visible quickly, clinical disk or something. Then again,
So that is
uh,
like clinical data to
yeah,
the
yeah. You
machine learning.
explained. I required this to understand. Try to understand, but not able
Okay.
to. Please.
Okay, got it. The first one is drug discovery, and another one is like system profiling. So these two are two different use cases. The first case is drug discovery, applied drug discovery using deep learning along with genomics. So the inputs are going to be genomic structures. For example, a particular disease would be there, right? That particular disease mRNA or gene-related structure that we can get it from bioinformatics, like the genomic structure is going to be acetine, thymine, guanine kind of things would be there. Along with that, a kind of characteristics of that particular genomics, and then what kind of drug molecules that we have found out so far. By providing it to the neural network, like by taking that data from it, like a lot of drug related databases are available, drug and gene related databases are available. They have this curated list of gene pattern. For example, for SARS-CoV itself, you can get the gene structure, the gene pattern right now from the some of the clinical databases. So once we have it, we can give it to the neural networks. The neural network cannot be a simple input and output based on our applications. If we wanted to profile it or if we wanted to predict the what could be the symptoms, or what could be the properties, or what could be the kind of impact of the drug and genome. We can build the customized neural network from it, and while training it, we can get the like proper like a new structure in the drug molecule pattern. That is one thing. And another one thing is electronic health records, HER, health-based electronic record, that is being collected in most of the hospitals, and 99% of hospitals in foreign countries. So by getting it, like in clinical data, we can get like what kind of patients are there, and then what kind of symptoms have been, and what kind of treatments have been given. By analyzing it, we can profile like, okay, this particular new disease, like the rare disease can occur with these kind of symptoms, and what kind of treatments that we can give, kind of like recommendation system, like when we have some symptoms, what kind of treatments and drugs we can provide based on the previous clinical data set we have, and we trained it on. So this is how like these two things are working. One is for one is for drug discovery, and another one is for symptom profiling. Yeah, if you have any doubts, you can ask.
Yeah, thank you, Mr. Prabhakaran. I need to go more for these things. Actually, required some specialist domain to go for this. Then because things are basically not from my side that regarding this how to initiate. So okay, thank you very much again for the nice explanations. To over to the students and other faculty members maybe there.
Yeah,
right? As I am able to look.
yeah, the thing is like since we have very limited time, and then this is not a major topic today. Like this is one of the topic that we have taken today. If it is like AI for biochemical industries, or AI for biopharma, if we taken that one particular thing, we would have discussed a lot, like for 1 or 2 or 3 hours, by putting up like case studies that we have, and putting up a proper proven architectures. There is an architecture for drug discovery. There is some architecture for symptoms classifications, which is like disease classification. There is a paper called paper for classifying detecting the COVID based on the cough sound from the patients. Like that cough can be analyzed by the natural language processing methodologies to classify it along with the symptoms. So if we have the symptoms and the cough sound, we can build a neural network model and classify, okay, this particular person has COVID. Instead of directly taking the CT scan or MRI scan, this could be the initial level monitoring, or initial level diagnosis. So a lot of research are going on. But the thing is, like, we need to have some time. We need to have ample amount of time to discuss a particular use case along from the end to end, like the data perspective, algorithm perspective, and the use case perspective. Thank you. If there is any question, I can take up. Yeah. How much math is required for AI and ML? At least you should. So the basic mathematical requirements are like linear algebra, graph theory, calculus. If you are probability and statistics, these are the 5 things. Like if you are aware of it, like you can easily understand. And another question is, what is the difference between machine learning and deep learning? So machine learning is the huge umbrella. So huge umbrella, as in like we can have n number of algorithms over there. Deep learning is only a family of algorithms which is dealing with neural networks. So machine learning can have random forest, decision tree, linear regression, XGBoost kind of things. Inside that machine learning, there is this new term called deep learning, which is only deal with neural networks. This is the difference between machine learning and deep learning. And deep learning seems to be very accurate because of that learning pattern, because others are just fitting the curves, or others are reducing the error. But here in deep learning, they are actually learning from learning as in like a very complex patterns. Like when you take videos, or when you take audio, or when you take scripts or images, and normal conventional machine learning technologies like k nearest neighbor or XGBoost and all, like will try to find very hard, very not be that much accurate, and also that will require like a separate feature extraction part. Whereas in the deep learning architecture itself will extract the features and it will try to classify or try to generate the results. This is the major difference between machine learning and deep learning. And what is the question from Rajan Chaudhary? Yeah, I have answered the question from Rajan Chaudhary. So mathematics is an important. If you want to learn mathematics for AI and ML, there is a resource called John Cron. You can search about him, John Cron. I can show you. Yeah, John Cron Maths. So you can follow him. Like he'll be teaching about like a machine learning foundational machine learning as in like mathematics for machine learning. You can learn it from this particular resource because like without mathematics we cannot judge, we cannot try anything out, we cannot experiment anything out. Is AI and ML applicable to all the fields of our life? As in like as you said during yeah. So at most all the fields can be like, for example, if you are running a small MSME, uh, you want like we can use machine learning to predict the sales for your shop, small departmental store, or if you are running a production plant, a small production plant where you are manufacturing the spare parts for Hyundai or Nissan. There you can implement like kind of like IoT based things, or even you can put some business related machine learning applications. Yeah, in all the industries or all the business area we can apply machine learning and deep learning. But ideally, the business impact should be higher than the invested money. For example, if you are investing some $1,000 or 1 lakh rupees for the particular project, ideally that particular business impact based on this AI or ML application should give you more than 1 lakh rupees, whatever you are investing. So data mining and machine learning, these terms and all like used interchangeably. But data mining, for example, when you have like huge amount of data, but you don't know about what are the important features or what features are going to impact your business, so, right? That finding out the proper data points for your business case study is going to be data mining, and machine learning is going to be like a predictive kind of things. Like data mining will handle like descriptive or inquisitive things like what is happening and why it is happening, to answer why it is happening. And machine learning will try to predict what will happen in the future. And is the role of data scientists only just building models and deploying? So it depends on the company. As in, like a few companies are doing from end to end, like from the data collection, data analysis, building the models and deploying it in the cloud. Or else, like a few companies are doing like building the models and converting them into a product, web application related product. And few companies are just building the models and deploying the models will be taken care by the DevOps team. So it depends on the company. We cannot find a proper job description for a data scientist or even a machine learning engineer. Like it is varying with respect to companies. For example, if a company has the machine learning engineer and data scientist, both of them in the same company, that roles will differ. Whereas only one kind of role is being called data scientist, that data scientist will do a lot of things. Whereas where a company has machine learning engineer and data scientist, right? But machine learning engineers are moreover right nowadays are moreover deployed in the works related to unstructured data called like um, uh, video, audio, speech, text related work and all. Machine learning engineers are data scientists are performing machine learning algorithms for business use cases like sales forecasting, demand forecasting, targeting the audience, customer churn analysis, digital marketing related things that data scientists are working on. And machine learning engineers are mostly working on unstructured data. This is the situation in most of the companies, but we cannot put a proper definition over there. But anyhow, like in this field, everyone will handle data, try to find the patterns, try to build the model, try to deploy it, and bringing it to the users.
Thank you, sir. That was really an interactive question answer session. And I would like you to share your email and contact means in case if students have some queries related to what they can pursue and any other means knowledge will content which they can get access from you.